This video is to show you how to do energy conservation with the spring. Word problem number 1. So let's read the problem. So David put a 2 kilogram weight on a spring and it stretched 0.65 meters. Now we know we're going to need the K if they don't give it to us, and they don't. So what they've done is they've just hung the weight on there and let it stretch. It's not bouncing up and down. So my force on the spring is equal to K delta X. That's Hooke's law. So my force will be 10 times that, so that's 20 equals K times my stretch was 0.65. So if I solve for that, my K equals 30.8 newtons over meters. Now, they ask how far the spring will stretch when I release. That means it's gone all the way down. So I start with the spring all tight. I let it go. And now the spring's all stretched out. And I've lost this potential energy. From here to here, I've got a negative H, right? So I've gone from here to here. All of that potential energy I lost turned into spring energy. So that means this spring energy has to equal my potential energy. So the energy of the spring has to equal my potential energy. So that means 1/2 K delta, we'll use H squared for X because we're going to use H for this formula right here. We either have to make them both X or both H because this distance is the same. The distance I lost is the distance in the spring. So that equals mgh. So one of these I can divide both sides by h's and one of those cancel. And since you needed h in both of them, and this is about the only way you can work it, is you have to set them equal. Because I can't find this without the h, and I can't find this without the h, so I have to set them equal. Now I can just plug in numbers. 1/2 times k is 30.8 times delta h equals the mass, which is 2, times g, which is 10. Now, depending on how you work that, if you wanted to say that my h should be negative because it's going down, that's fine. I'm just wanting how far it's stretched. I don't worry about on this one whether it's positive or negative. So when you solve all that, you get that the h equals 1.3. So technically we should say the h is negative 1.3 because it's going down. But I will accept either one. The worksheet points that out, but I would really accept either one.